Hi, myself Preeti, BSc Chemistry Honors Final Year, roll number 67. Today, this is a video of visual impaired on the topic of fats, oil, and detergent. Starting with the introduction, oils and fat are widely distributed in nature both in animal and plant kingdom. In animal, they are present under the skin and in muscles, but in plants they are mainly found in seeds. Some important example of fat are butter, lard, and tallow, beef, etc. While groundnut oils, coconut seed oil, olive oil, palm oil, coconut oil, sunflower, etc. are important example of vegetable oil. Fats and oil are one of the three major constituents of our food, the other two being carbohydrate and protein. In fact, the fat and oil served in reservoirs for the animal. In human being, only few hundred grams of glycogen can be stored, which can barely supply the body energy needs, but for about 12 to 18 hours. In contrast, large amount of fat can be stored which can supply the body energy needs for but about 8 weeks. Beside this, oil and fats served as raw material for a number of industries such as soap, paint, varnish and vanaspati ghee etc. Natural fats. The fats obtained from animal source such as butter, lard from hogs and torn from sheep, goat, etc. are called natural fats. This name is simply given to differentiating these fats from those fats which are obtained by hydrogenation of oil. Edible oil and non-edible oil. Oils such as groundnut oil, sunflower oil, soybean, etc. are used for cooking purpose, which are called edible oils, while oils such as cottonseed, linseed, castor seed, etc. are used in soap, paints, liquors industry are called non-edible oils in industrial oil. In non-edible oil or industrial oils. On the basis of iodine values, oil has also been classified as drying, semi-drying, and non-drying oils. Industrial oil may include essential oils or mineral oils. Essential oils such as rose oil, jasmine oil, lavender oil. Essential oil may be hydrocarbon, alcohol, aldehyde, ketone, ester, etc. For example, peppermint oil contains methanol as its chief constitute. Essential oil are mainly used in perfume, cosmetics, and pharmaceutical products. On the other hand, mineral oils is a mixture of saturated and unsaturated hydrocarbon and not ester or triglyceride. Triglyceride composition of oils and fat. As stated above, fats and oils are triesters of glycerol with higher aliphatic monocarboxylic acid. In other words, they are triglycerols and are commonly known as glycerides. Here is the structure of triglycerol. Next is fatty acid. With only a few exceptions, all the monocarboxylic acid isolated from fat and oil are straight chain compounds containing 3 to 18 carbon atom. Further, with the exception of only carbon 3 and carbon 5 acid, all other acids are found in fats and oils contain even number of carbon atoms. The chief saturated fatty acid present in oil and fats are leucuric acid and some stearic acid and other you can see. Besides saturated fatty acid, unsaturated fatty acids contain one or more double bond in cis orientation may be present in oil and fats. The chief unsaturated fatty acid present in oil and fats are given below. Next is classification of glycerides. The three fatty acids in glyceride may be same or different. Therefore, glycerides are classified as simple or mixed glyceride according to they have the same or different acid residue. For example, simple glyceride and mixed glyceride. Example are shown. Glyceride are further classified into saturated and unsaturated glyceride according to as they contain saturated fatty acid residue or unsaturated fatty acid residue. Both simple and mixed glyceride are found in nature oil and fats. In fact, oil and fats are complex mixture of mixed glyceride along with the small amount of simple glyceride. Chemical difference between oil and fats. The main difference between oil and fat is the proportion of saturated and unsaturated glyceride. Triglyceride with the higher proportion of saturated acid residue such as palmitic acid, stearic acid and are solids at ordinary temperature and are called fats, while those with higher proportion of unsaturated and residue such as oleic acid, linoleic acid, etc. are liquid at ordinary temperature are called oils. Next, we have melting point of glycerides. As stated above, fatty acids have one or more double bond having less stable cis and cis stereochemistry. For example, oleic acid has a cis double bond at C9, leonic acid has two double bond at C9 and C12, while leonic acid has three cis bond at C9 and C12 and C15 position. The cis bond have vital or biological importance in the solid state molecules of saturated fatty acid fit closely in crystal lactic due to their zigzag tetrahedral structure. On the other hand, cis unsaturated fatty acids have bent at a double bond and hence do not fit closely, thereby lowering their melting points. Talking about chemical properties. Fats and oil being tri-estered by of glycerol show all the reaction of simple ester in case the glycerides contain unsaturated fatty acid residue. They also show the unusual addition and oxidation reaction of alkenes. Some important reactions of fatty fats and oils are given below. Hydrolysis. Fats and oil are readily hydrolyzed by treatment with the superheated steam mineral acid or alkalis. Hydrolysis by superheated steam or mineral acid gives a mixture of fatty acid and glycerol. However, when the hydrolysis is carried out by alkali, glycerol and salt of fatty acid are formed. Since the salt of higher fatty acid thus formed are used in soap and the alkaline hydrolyzed is commonly called saponification. In the digestive system of human being and animal, fats and oils are hydrolyzed. Glycerol and fatty acid is a number of enzymes called lipase. Second, hydrogenation. Oil which contain higher proportion of unsaturated glyceride add on hydrogen in the presence of finely divided nickel as catalyst to form a solid fat. For example, trione and tristyrene. The process of the process is called hydrogenation of hardening of oil. It is similar to catalytic hydrogenation of alkenes and involves the reduction of double bond present in unsaturated glyceride to form saturated glyceride. The process is extensively used in manufacturing of vanaspati ghee from groundnut, peanut, sunflower, and other edible oils. Hydrogenation is never carried out in completion, but it is stopped as soon as the fat of consistency comparable to ghee is obtained. The completely hydrogenated fat are too hard to be useful in kitchen shortening. The main advantage of hydrogenation is that as compared of oil, fats and have storage quality of and do not become rancid easily. Third, hydrolysis. Conversion to alcohol, fats and oils on treatment with hydrogen at high temperature and pressure in the presence of copper chromate as catalyst undergo reduction cleavage to form glycerol and long chain aliphatic alcohols. For example, tristane to glycerol under high temperature. The splitting of fats or oils to glycerol and a higher long chain alcohol by hydrogen is called hydrogenolysis. The long chain alcohol thus produced are used in manufacturing of synthetic detergent. Fourth, transesterification. Fats and oil can be converted into simple ester of carboxylic acid such as methyl ethyl ester, etc. by transesterification. It involves the treatment of fat and oil with a large excess of suitable alcohol in the presence of acid or basic catalyst, for example, given below. The process of transesterification is quite useful for the large scale preparation of long chain fatty acid and long chain primary alcohol of higher purity. For this purpose, the mixture of methyl ester obtained by transesterification is subjected to fractional distillation to separate the individual ester. These upon these upon hydrolysis yield fatty acid of higher purity. Alternatively, the individual methyl ester are reduced to get long chain primary alcohols. Number 5, addition of alcohols like alkene unsaturated glyceride add halogen across the double bond to form additional products. The addition of iodine is usually carried out by the treating the fat or oil with the iodine in the presence of mercury chloride as catalyst. Sixth, rancidity. When fats and oil are exposed to warm air or moisture for a long time, they develop a disagreeable smell and taste. The process is called rancidity and involves the hydrolysis of ester to produce a fatty acid and oxidation at a double bond to form short chain acid and aldehydes. The short chain acid and aldehydes are volatile and have often offensive smell. Therefore, they impart unpleasant odor to oil and fats. Rancidity is the following two type. Rancidity is of following two type. Hydrolytic rancidity. This type of rancidity is caused by liberation of lower fatty acid and hydrolysis of triglycerides. For example, when butter is exposed to warm air and moisture, the hydrolysis of glycerol in butter yields butyric acid and volatile acid with the unpleasant odor. Second is oxidative rancidity. The type of rancidity is caused by oxidation of unsaturated triglyceride by the air to form short chain acid and aldehyde having unpleasant smell. It is believed that the ester linkage and hydrolyze to yield unsaturated acid, which undergoes oxidation at a site of double bond to produce short chain acid and aldehyde. For example, given below. Now we have analysis of fats and oil. Fats and oils are extensively used in a number of industries. Therefore, it is essential to check the quality of given fat and oil. This involves the determination of physical constants such as melting point, specific gravity, refractive index, etc., and the chemical constants such as acid value, iodine value, saponification value, etc. Some important some important chemical constants are described below. Number 1 is acid value. It is defined as the number of milligram of potassium hydroxide required to neutralize the free fatty acid present in 1 gram of fat or oil. Second is saponification value. It is defined as the number of milligram of potassium hydroxide required to completely saponify 1 gram of fat and oil. In other words, it represents the amount of potassium hydroxide in milligram required to neutralize the fatty acid formed as a result of complete hydrolysis of 1 gram of fats and oils. The saponification value gives an idea about the molecular weight of fats and oil. Obviously, the smaller saponification value, higher molecular weight. For example, tripalmitin molecular weight is 806 and has saponification value of 208, whereas trileucrate with the molecular weight of 638 has a saponification value of 263. The saponification value is also indicated the length of carbon chain in the acid moiety present in oil and fat. The higher the sonification value, greater the percentage of short chain fatty acid in glycerol of the fat and oil. Butter with a short chain fatty acid has sonification value of 210 to 230, whereas soybean has a sonification value of 189 to 195. Third, iodine value. It is defined as the number of gram of iodine that will combine with 100 gram of fatty acid and oil. Iodine value may be determined by any one of the following method. First is Hubel's method. In this method, a solution known as weight of the fat or oil in CCl4 is allowed to react with the known excess of standard solution of iodine in ethanol in the presence of mercury chloride as catalyst. The unreacted iodine is determined as titrating it against the standard sodium triosulfate solution using starch as indicator. For example, the iodine value of trionyl may be calculated as following. Second is Witt's method. In this method, a solution of more reactive iodine monochloride in a glacial acetic acid is used in the place of iodine and mercury chloride. A known weight of oil and fats is dissolved in CHCl3, which solution is then added. ICI adds across the double bond, and the ICI left unused in the treated with Ki solution to liberated an equivalent amount of iodine. The liberated iodine is then treated with the standard hypo solution of starch as indicator. The amount of ICI has added across the double bond is then determined using the following relation. Fourth, Richard Missel value (RM value). It is defined as the number of milliliter of 0.1 normal KOH required to neutralize the steam volatile fatty acid obtained by complete hydrolysis of 5 gram of fats and acid. To determine the RM value, a known weight of fat or oil is completely sonified with alkali. The resulting solution is acidified with the dilution H2SO4 and then subjected to steam distillation. The distillated, which contains the volatile acid, is then treated against 0.1 normal KOH solution. The RM value is then calculated as following. Next, we have industrial oil or vegetable origin dyeing oils. Certain oils such as laced oil, tongues oil, etc. are when exposed in air in thin layer form a hard or tough water insoluble solid. The process is known as drying. In such a oils are called drying oils. Oils like olive oil, groundnut oil, etc., which do not dry and on exposing to air are called non-drying oils, and those which dry, such as cotton oils, are called semi-drying oils. Chemically drying oils contain a high percentage of unsaturated glyceride as shown by their high iodine value. On the other hand, non-drying oils have low iodine value while semi-drying oils have intermediation iodine value. For example, drying oils have iodine value of above than 150. Non-drying oils have iodine value of 100. Meanwhile, the semi-drying oils have iodine value of 105 to 114. Drying oils are used as a medium for paints, varnish, liquors. In fact, paints are suspension of some pigmentation or in the organic color matters in linseed oil to which some turpentine oil has been added as a thinner. When these paint are applied on any wood or iron surface in thin layer, they quickly dry up and to form a tough organic film on the which protect the surface that is being painted. Next we have mechanism. Now talking about soaps. Substance like soap and synthetic detergent which concentrated at the surface of a solution or interface from surface film reduce surface tension of the solution and can help in removing dirt and dust by emulsifying greasy area called surface active agent or surfactant. The molecule of surfactant contains two characteristic group, one which has the water soluble and other which is oil soluble. Soaps are the sodium and potassium salt of higher fatty acids such as palmitic acid C15H31COOH and citric acid C17H35COOH and oleic acid C17H33COOH. The soap are generally contained by the hydrolysis of oils and fat with the aqueous alkaline. The process is called saponification of oil and fats. For example, given below. The fats and oil commonly used in soap manufacturing are town, lard, olive oil, linseed oil, etc. Soap containing 12 to 18 chain atom of good cleansing action soap with 12 carbon are comparatively soluble in water, whereas soap with 18 to 12 carbon atom are not useful soap because they are insoluble in water. Sodium soap are generally hard and hence are called hard soap. They are used in washing clothes. Potassium soap are on the other hand are most expensive soaps. Produce softener latrine and hence are called soft soaps. They are used for making shaving creams, shampoos, liquid, etc. Transparent soaps are prepared by dissolving ordinary soaps in alcohol and removing insoluble part by filtration, evaporation of alcohol, leaving behind transparent mass. Soaps are 100% biodegradable. For example, microorganisms present in sewage water can completely oxidize soap into CO2. As a result, it does not create any pollution problem. However, soap have two disadvantages. Number one, soap cannot be used in hard water since calcium and magnesium ions are present in hard water produce curdly white precipitates of calcium and magnesium soap. Second is soap cannot be used in acidic solution since acid precipitate the insoluble free fatty acid which adhere to the fabric and thus block the ability of soap to remove the oil and grease from the fabric. Next we have synthetic detergents. These days, in place of soap, the substance which are being used largely is used as a cleansing agent are synthetic detergents. As the name suggested, they are obtained from purely synthetic chemical as compared to the soap which are derived from chemical which is obtained from a natural source like oils, fats. In fact, a synthetic detergent are derived from chemical are sodium or potassium salt of long chain alkali hydrogen sulfate or aryl sulfonic acid. Unlike soaps, magnesium salts of detergent like their sodium or potassium salt are also soluble in water. Hence, synthesis detergent do not form curdly white precipitate with hard water. Further, they can be used in acidic solution. However, synthetic detergents have one disadvantage. Unlike soap, they are completely biodegradable and hence cause water pollution. Synthetic detergents are of following three types. Number one, anionic detergent. They are so called because large part of their molecule are anion. These are of two types: alkyl sulfate. They are obtained from long chain alcohol by treatment with concentrated H2SO4 followed by neutralization with NaOH. Some important example of this type of detergent are sodium lucric sulfate and sodium stearic sulfate. Number two is alkyl benzene sulfonates. These are obtained from conversion of benzene into a long chain alkyl benzene followed by sulfonation and deuterization with NaOH. The most widely used domestic detergent in sodium bensulfonate. Alkyl bensulfonate in which the phenyl group is either attached to the end of long alkyl chain or any other secondary position have higher biodegradability and hence are called soft detergents, while alkyl benzene sulfonates having branched chain alkyl group have poor biodegradability and hence are called hard detergents. To differentiating these detergents on the basis of biodegradability, alkyl benzone sulfonate having a long straight chain such as sodium P and 2-dichlobenzene sulfonates and sodium 2-decyl benzene sulfonate are called LAS detergent. It is prepared from Frindle-Craft reaction of tetramer of propylene and with benzene followed by sulfonation and neutralization of alkali. Cation detergents. These are the quaternary ammonium salt containing one or more long chain alkyl groups. These are called invert soap because their surface activity is due to the position positive ions or and hence not to a negative ion as a alkyl hydration sulfate detergent. Being more expensive than the anionic detergent, they find limited use. Beside being good cleansing agent, they are possessed germicidal properties and therefore they have widely used as germicides in hospital. Third, non-ionic detergents. These are esters of higher molecular masses alcohol obtained by the reaction between polythene glycolic and stearic acid. These may be obtained from long chain alcohol by treatment with excess of ethylene oxide in presence of base. Now we have composition of detergents cake. A cake of detergent contains about 20% of active detergent and an equal amount of sodium sulfate to make up the bulk of the powder. A further 30 to 50% sodium tripolyphosphate or STPP is added as an additive. It coordinates with Ca2 positive and Mg2 positive ion present in hard water and thus enhance the cleansing efficiency of detergent. Other ingredients include sodium perborated which act as a bleaching agent, some optical brightness or fluorescence that is organic compound which make yellow cloth appears white and some foaming agents. Detergent pollution. Detergents having branched in hydrocarbon chain cause pollution in river and other waterways. The reason being that side chains stop bacteria from attacking the breaking of chain. The result in showing degradation of detergent molecule leading to the accumulation since unbranched chain are more prone to attack by bacteria. Therefore, in most of the detergent used these days, the branched is kept to a minimum so that the detergent became easily biodegradable and pollution is prevented. The second serious environmental problem is caused by phosphate additive that is STPP which are discharged into river and lake from sewage system. As such, phosphate is not a pollutant, but it is actually a fertilizer. The excess of phosphate promotes the growth of water plants, which in turn deplete the water or availability of oxygen for fishes and other aquatic animals. As a result of want of oxygen, water animals die and rot. In other words, lake became full of dead animals and vegetable and hence ceased to act as a source of potable water. Now we have cleansing action of soap and detergent. All the soap and detergent contain two characteristic group water soluble hydrophilic and a water insoluble and oil soluble lyophilic. As a result, one ends of the molecule detergent tends to go into oil phase and other ends tends to go in the water phase with the net result that the material concentrated at the surface of solution interface. The dirt is generally held to dirt surface by the thin film of oil and grease. When the dirt surface is treated with soap solution, the non-polar hydrocarbon chain of the soap and detergent dissolved in oil or grease with the hydrocarboxylate group of the soap or the sulfonate group of synthetic detergent is held by surrounding water. This loweration of surface tension between the water and grease, as a result, a stable emulsion of oil in water is formed when the surface or the cloth is mechanically scrubbed. This loosened dirt particle and absorbed by colloidal soap or detergent participating and ultimately washed away.